The idea of taking your passion and turning it into a business is often part of the conversation we have with entrepreneurs. It is the core of how our guest, Kirk Anderson, co-founder and director of operations at SQ4D, combined a passion for design, architecture, and technology to ignite an idea to scale up 3D print technology to construct the first 3D printed home. In this episode, we'll hear how a self-funded team built and programmed a supersized 3D printer to extrude layer upon layer of concrete to form the primary structure of a house that recently went on sale and is revolutionizing the construction industry. Hi, Kirk. Welcome to our podcast series.
Thank you for having me. How are you, John?
Very well, thanks. Appreciate you joining. Your company, SQ4D, has been all over the news of late, especially with your successful completion of a 3D built home here on Long Island. Before we get too far, though, I really want to understand your background and how you got into this business.
Sure. In my opinion, I'm not really a highly intelligent person, never finished college, but I love architecture, I love design and technology. I've been a graphic artist throughout school. I wound up working construction for about 10 plus years. I love carpentry. I love building furniture. I enjoy working with my hands. And I think I grew up at a great time, in my opinion. I've experienced a lot of technological advancements, and I'm always trying to stay on top of that. So I got into 3D printing a bunch of years ago, linked up with a friend, and long story short, we took a regular desktop 3D printer, scaled it up a couple times to where we're at now with a full-size house printer, if you want to call it that. We print footings, foundations, interior and exterior walls with a concrete printer. So we've developed everything in-house. We're privately funded. And I think we're just going to continually optimize the system. I have a yearning for just design. I'm passionate about that. And I think right now the machine is awesome and it's very capable of printing houses. But we're just going to continually optimize that, make that better, and put this around the world. This is here to stay. This is a game changer. Additive manufacturing is going to change the construction industry and obviously many other industries.
Yeah, additive manufacturing really affected nearly almost every industry, from healthcare to aerospace and now construction. And it seems as though your company has successfully put together, I would say probably robotics, software, both design and application software, as well as material science in terms of, I would imagine the mix of concrete isn't something we go to Home Depot and buy a bag and you fill that in. I would imagine this is something special. So maybe you can walk us through how you took it from, and you said you started out small scale, 3D printing, probably with a desktop machine. And then how did you scale that up? What did you have to pull together in terms of resources to bring you to where you are today?
Yeah, so it's the main principle behind 3D printing is a coordinate plane. You have a couple axes, and you instruct the machine to go somewhere and deposit something. So we're taking the desktop 3D printers that work with plastic, and they're great. You can rapidly prototype parts and produce things. I use them on my mountain bike every day. I use things to make cast molds. I love 3D printing. So we took that idea and we scaled it up to about like 6 feet by 10 feet. We made a small machine. It's quarter scale of our large industrial machine. With this quarter scale machine, we learned a lot. We dumped a bunch of money. We found the right materials to build this machine out of something that's going to be corrosive resistant and something that we can use. And it's still a usable tool. Even though it's on the smaller end, I can print fences. I could print sewage and drainage components. It's a tool. So we scaled that up from a desktop printer to the plastic printer. Then we got some concrete going through the system. We were stacking layers. We found some mixes that worked, some that didn't. Then we jumped right into building the large scale machine. And we even learned more on that. We were hand mixing concrete. We couldn't do that. You can't keep up with the output. Right. So then we had to get a volumetric concrete mixer, which we mix the concrete on demand on site. So it's not as easy as going to Home Depot and getting a bag, but we're using locally sourced materials, Portland cement, fine sand, and water. We've experimented with additives, and we're just trying to keep it simple. We're trying to make this something that's readily available. So if I go to Dubai, New Zealand, anywhere, that you can put material through this machine and extrude and produce a structure, produce a fence, produce roads. This is just a material delivery system. We've developed all of this. Like you said, there's been a lot of work here in the software, in the mechanical end of it, in the materials. We've tried many different mixes. We've had them tested for compression. We've tried fibers. We've tried using aggregate. It's not necessary for the way we extrude. And we're still learning here. I think the material is going to evolve and the software is going to evolve. But at the end of the day, we just have a tool, a machine to show up on site and extrude this material, whether it's a geopolymer with recycled materials, which I foresee happening, or simple as concrete, which is a strong, cheap, abundant material that we've been using for thousands of years. So I hope that people don't think that these houses are made of plastic, but we're using a very Portland cement-rich concrete. We extrude it at 1.5 inches wide by 3/4 inch tall, and we found that as a sweet spot. We can stack our layers and support the continual layers after that. And within these walls, we're doing everything that the engineering and architects are asking of us to allow for insulation, the proper spots with rebar reinforcements, and we're also putting insulation in all the utilities in the wall. So this whole system can be completely automated. Right now, we're doing about like 42% of the home. And eventually we're going to do more. You're going to do roofs. You're going to do masonry things throughout the house. You can do a bathtub, a hot tub. And that's just the concrete right now. And that's just where we're at right now. We're just scratching the surface here. But it's not a complex process, but it can be. So we're just trying to make this simpler and simpler as we go on. We use desktop 3D printers to make parts for our big 3D printer. There's some fun stuff going on here. But at the end of the day, we're just trying to build houses. We're trying to build regular houses. I mean, we could build tiny houses, but we want to build regular full-size houses. And we're striving to provide shelter in half the price and half the time. That's a big goal of mine.
So I want to talk about the company mission a little bit. And what I found interesting, because you talk about this a lot in terms of really make housing affordable and provide opportunities for housing for people that really couldn't afford it before. Is that part of the central mission of your company?
That is probably the biggest priority, is to make housing more affordable. And with automation, we can do that. Right now, maybe I'm not cutting tremendous costs, but automation will disrupt the construction industry in many ways. It will ripple out to everybody that follows, from the contractors to the home buyers to the material suppliers and the contractors and the builders on site. This is going to evolve over the next 100 years to where the point we're not swinging hammers anymore. There's robots doing the work. They're doing it very precise, and they're doing it more sustainable, where we're actually watching exactly how much material is going through. We can calculate this all. There's less transportation of goods, and we're reducing the amount of screws and nails and glues and foams. And a mission is to make building houses more affordable, making the houses more affordable. But at the end of the day, the market will dictate the price of the house. And that's a big point, is on the location. Everyone says location, location, location. But geographically, New York is very expensive to live. But if we went in the middle of the country, I still can make houses cheaper than they can. So we're really pushing the affordability of housing. And then also, a big thing for me is the safety. We don't have 30 guys on site climbing ladders, swinging a hammer over their head. We have antiquated processes right now. We're better than this. We've made advancements. It needs to happen to combat these rising costs of lumber and steel, and also the labor cost. If you want good labor, it's not really cheap. And you want cheap labor, it's not very good. We're trying to get good, fast, and cheap out of that. And you don't get that with a lot of things. I think additive manufacturing is showing that can happen, like you said, in hospitality, in medical fields, and now in construction.
Yeah, I think you call it the gantry system that actually applies it. You call it, I think, an autonomous robotic construction system. So you have essentially, instead of having, let's say, 10 workers on site, all you need maybe is 2.
Yeah, I can explain that a little bit. We have the machine. It's a printer. It's an additive manufacturing machine. It's a CNC machine. However you want to look at it, this thing just goes where it's told to go based on instructional G code. That is one part of it. Then there's a concrete pump. That is the other part of it that delivers it to that system. But to mix the concrete on site, I need that mixer. So I mix the concrete, I put it through the pump, I put it through the hose, and this machine goes around. I can eat lunch and watch walls being built. As long as I feed this material, it's going to go. It's going to go, however, and it's going to do the events and any structural pieces. It's going to stop and allow me to put the rebar in. Right now, I can build a house with 2-3 guys. In the future, it'll be one guy watching 10 of these machines in a shed all on a computer, making sure that the material is just being fed. We can literally automate all these processes and have multiple houses being built by robots on site in a development for disaster relief, for just to make this stuff more affordable. There's so many avenues to explore, so many shots on goal, that we're just scratching the surface here, like I said.
You mentioned a few things. First off, elimination of all the screws. And probably most construction sites, you see a tremendous amount of waste. And I would imagine that your process is much more efficient, reduces the amount of waste. But what about from an energy aspect? Does it use more electricity? Is there more water uses? Or is it you're saving on every level is kind of what my question is.
Yeah, you really are saving on every level. So the actual printer itself runs on about the same wattage as a hairdryer. So that's not crazy. That's way less than most generators on job sites. And then our concrete mixer and our pump can be run off of diesel. And then eventually we're hoping to capture the emissions from these diesel elements and then maybe encapsulate that carbon output into the concrete. That's a whole nother discussion. But the sustainability is really in the material savings. What I like to explain to people is subtractive manufacturing with normal CNCs and how we make metal parts. We take a block of metal and we cut it down. So you're wasting all that material. But additive manufacturing, we have a controlled amount of material and we're extruding that through a system knowing exactly how much is going through. So you can know exactly how many bags of Portland you need, exactly how much water, And the same thing goes for the rest of the house. We will know where all the outlets are. We will know where all the plumbing is. We can really get this down. I mean, there's a whole industry around this already. It's called BIM, Building Information Modeling. There's a way we can calculate this all, simulate this all to make sure that everything checks out dimensionally, structurally, and financially, all on paper, to make this more sustainable, to make more sense for the future, because we need to cut back on the waste. We need to stop putting things in landfills. We need to make more sense on job sites, because right now it's a pretty rough, rugged kind of feel. I mean, I've been on job sites. If you've been in construction, it's not always the prettiest thing. We can make this a little more professional, a little more pretty with robotics, automation. A big thing for me, like I said, is the safety. You're not going to have as many guys on site, and we're going to be having some higher wage engineers or operators for these machines. So you don't have as many people on site that have the chance to get injured or a fatality happen. And the numbers are through the roof right now. So we do need to reduce that, and automation is going to make that happen.
And also, I would imagine you're accelerating the time frame in which to complete a house.
Exactly. We're getting on-site and off-site way quicker. This is the early stages. There's not enough data to maybe give to you right now, but this is going to make job sites a lot quicker. You're going to be able to get a house in half the time.
And in terms of employment opportunities within the industry, then, it almost sounds like you'll be looking for more designers, engineers, on-site project managers. It won't eliminate every job, but it may create new opportunities.
Exactly. I think we are creating it's a whole new industry. I think this is like a Ford moment, an assembly line moment, is where we're disrupting a lot of fields with additive manufacturing. And the digitalization of these industries, digitalization of construction, is going to create jobs that we can't even think of right now. The way an architect talks to an engineer, talks to that home builder, that's going to be hopefully a more expedited process. It'll be on a flash drive, and you can just say, here, boom, make the G code for the machine, and you're there, and that's approved. And like, who's really building the house? The robot is. We're just providing the material, and you inspect it at the end of the day to make sure it's all good. We do compression tests during the day to make sure this concrete is good. So we're going to get down to the point where there's going to be specialized jobs for people, and we're creating those. And the industry is going to make that happen. The industry is going to dictate the type of jobs we need and where we need them. It's exciting to be a part of.
And the other thing that was amazing to me is, in doing a little bit of research, this has evolved very fast. I read a few articles about companies in Europe within the last, I'm going to say maybe 8 years, started out by doing almost like a 2D parts that would go into a construction site. So they would do a flat piece that would then have to be added to something else. But it's already evolved to where now you're doing everything three-dimensionally. You're putting the concrete. No one has to pick something up and put it in place. It's there already. So it seems like it's how quickly it's evolved, and it will continue to evolve.
Yeah, this is really taking off. It is happening internationally. And there's building codes all over the place that are very different. So people are allowed to do a little bit more here, a little bit more there, experiment a little bit more. And we're just proving it out in our way. There's different machine designs out there, but there are a lot of people attacking this industry, seeing the benefits. And right now, it might not make the most sense to some people, but in 20 years, this is going to be everywhere. It will be.
I see that. And what's been the reaction from the consumer aspect? I did read a few articles that as soon as you said that you had a house for sale, were people lining up to buy it?
Yes, we've been inundated with calls and offers, and people who want to see the house, want to see the process, want to buy machines. We've been inundated at all angles, but you put a house for $299 in a neighborhood that most houses go for $500 plus. It's a good thing. So we've had tremendous interest, offers above asking, and this is the first house of many. This is going to be the first house on the market. This is a brand new thing. We're not even sure exactly how to handle it, but we're doing our best. And the market dictates the exact selling price, and the market's going to dictate where we're at. But we're hoping that we can get in, do our thing, and get out, and allow other tradesmen, the plumbers, the electricians, to do their thing and optimize that process so they can cut costs, so that we can overall reduce the price of that product, which is a house that someone will live in and raise a family in. And this is a concrete structure. It's going to last. So we're just trying to do a good job to make this practical for everybody, to have the home buyer understand, the real estate agents, brokers understand what's going on here. We're just building a house. Instead of laying bricks, we're laying beads of concrete.
Now, in terms of the growth for your company, where do you see it going from here? I mean, you mentioned that you've been getting inquiries for both the machine as well as for constructing homes. Do you see yourself maybe filling both roles?
Yes, it's very possible to do both. I mean, even if we sell someone a machine, we have to train them. They don't know how to use it off the bat. And it's our own system, and we have our own ways. Like I said, other people have different machine designs, and they're going to have to teach people how to use their machine. There's not going to be an exact industry standard. Eventually, it'll get down to the nitty-gritty of what is the best.
Right. And I would imagine that's what you're looking for, is to be at the pinnacle, at the top end.
Yeah, we've proven that we can build full-scale size houses compared to some of these huts that I've seen. And it's all good. We're all trying to make housing more affordable, get people one of the basic necessities. It's shelter, but we're leading the way with our simple system. It's easy to understand, and once you watch it, it's pretty captivating.
To scale up from here, will the company then go out and look to maybe do some level of financing, or where do you see the company growing from here?
It's definitely going to take off a little bit more. We're scaling up every day. I'm hiring people. I'm trying to advance how I print, the mix, all aspects of our company. But yeah, we're privately funded right now. We're happy with that. We're in all control. But we will want to take this to another level, producing thousands of these machines. So we're looking for partnerships, collaborations, something to happen. But we'll take our time with that and make the best decision that we can.
Excellent. And how many employees do you have now?
Under 12.
Wow. It's amazing what you've accomplished, and especially since you're doing it as a self-funded entity. And, relative to the organization, one of the things that sort of captivated me was the name of the company, SQ4D. What's behind the name?
So we started out, like I said, making the desktop plastic 3D printers, and we were under the brand of S Squared 3D printers, our SQ3D. And we started to develop the large concrete printers and wanted to rebrand. And we came up with SQ4D. 4D is another dimension past 3D. We like the look of it. We like the sound of it. We made the logo, and we're pretty happy with the name.
Well, it's going to be a brand that will become, hopefully, a household name going forward, right? A couple of questions for you, Kirk. What one word describes who you are?
Persistent.
Persistence is important when you're an entrepreneur.
You need persistence, and I like another word is consistent, because we need to break this down scientifically and get good results and learn from those results and build off of those results. It's just a step-by-step process of advancing. Like I said, I'm not the most intelligent person. I'm still kind of young, so I'm still learning and getting more experience and wisdom as we go. But being persistent is huge in my life. And
what advice do you have for future entrepreneurs, for budding entrepreneurs out there?
I would say that gold is rarely found on the surface. You have to dig. You got to put in the hard work. You got to make the sacrifices now while you're young, and they'll pay off down the line. We have so many resources, so many references, technological advances. We have a computer in our pocket, and we need to make the best use of that, the best use of your surroundings. I think if you surround yourself with the right people, if you're observational around your environment, and you're really engaged, you're going to kick ass. Just do whatever it takes right now. While you're young, is make the sacrifices. You don't have to go to every basketball game. You don't have to go to all these parties. Better yourself, better your environment, better for your family is to put in the hard work now and reap the benefits later.
Oh, that's great advice. Kirk, listen, thanks so much for joining us. And I know our listeners are going to get a lot out of this, and thanks for sharing.
Thank you for having me, John. If you need anything else, you got my number, you got my email, or if you want to visit our website, sq4d.com, to learn a little bit more about us, I'd be happy to answer any other questions.
Wonderful. Thanks. The story begins with passion sparking an idea. Kirk started by connecting his construction experience with his love of design, architecture, and technology. Then, working with his partners, they identified the attributes of additive manufacturing using 3D print technology to automate building a home. Finally, they identified specific problems with the traditional construction process, including high labor costs, waste, and worker safety, that a robotic concrete printer could overcome. These are critical elements in their startup strategy: to recognize a problem, apply their passion and experience to develop a solution, and identify a market. Although this is about a tiny Long Island, New York-based startup producing and marketing a 3D printed home, it is more about industry disruption and identifying a global market for a technology that can democratize homeownership or quickly provide shelter in a disaster. But none of this is possible without hard work and persistence. As Kirk said, gold is rarely found on the surface. You have to dig. You got to make sacrifices. Take advantage of the many resources available to you. Surround yourself with the right people. Be observant. And whatever you do, work to better yourself, your environment, and your family. We thank Kirk for sharing his insights and his inspiring story. This podcast is executive produced by John Rebecki and New York Institute of Technology in conjunction with the School of Management and the Office of Strategic Communications and External Affairs. The Director of Professional Enrichment and producer of this podcast is Deborah Cohn. Our marketing and social media strategist is Petra Shantaraga. Our audio editor and mixer is Brian Falk from Abacus Entertainment. Special thanks to Constance Talacia and Paulana Lamanier for all their support. Until next time.